Hi everybody, this is Dr. Burns. We're going to take a look today then at section 7.5, which is where we are making confidence intervals where we compare the population proportions for two different populations. So in the previous section, we created a confidence interval estimating the proportion for one population. Now we want to compare the two populations to see if there are any differences in those two population proportions. So let's take a look at this first example as a scenario. It says a June 2025 poll asking the opinions on the GOP's budget and tax bill was conducted by Pew Research. Pollsters found that 77% of the Democrats surveyed believed that the bill would hurt middle-income earners, while only 52% of Republicans surveyed, same idea, felt the same way. Suppose that there were 540 Democrats surveyed and 537 Republicans surveyed. So the thing we want to determine is we see that the differences in the samples, the percentage in the samples are different. But what we want to know is, does that really reflect a difference in the two population proportions? Or could this just be by chance? Could the samples have just differed by chance? We know that samples fluctuate all the time. But does this really reflect a real difference in the two population opinion, the proportions rather, between Democrats and Republicans on this issue? So it says, under sample proportions, it says, even if two population proportions are equal, the sample proportions drawn from those populations are usually different. So confidence intervals give us a way to determine whether those sample proportions reflect real, true differences in the population proportions. So the way we're going to handle this is very similar to how we created a confidence interval back in 7.4 with just one population. We're just going to extend it a little bit and look at some interpretations. So our comparison of two population proportions will now be based on the sample statistic P1 hat minus P2 hat. So P1 hat and P2 hat are the two sample proportions. You can define which one is P1 and which one is P2, but the difference between them in the sample proportions, that's our test statistic. And then this statistic will be used to estimate the difference between two population proportions, P1 minus P2 without the hat. We're going to find a confidence interval for the difference between P1 and P2, and then we're going to check to see if 0 is included in the interval, and then interpret as indicated below. So down here, this is the part that you really want to pay attention to. This is the part you're going to need to remember. There's basically three scenarios. So when we create that confidence interval looking at the estimated difference between P1 and P2, there's three things that could happen. And what I think I want you to do in the notes is add a little something to this table, because I didn't leave you a ton of room here. So over to the side, I'm going to add sort of another column. Let me see if I can draw this for you. I'm going to add another little column over here. Well, just do the best you can as far as space. So there's three things that could happen. One thing that could happen is the confidence interval could contain 0. And if that happens, that tells you that the two population proportions may be equal. Now, mathematically, why does that, or what does that mean? Why does that occur? Well, if P1, remember you're estimating the difference for P1 minus P2. So if that difference could equal 0, essentially what that tells you is that P1 could equal P2, right? Just move the P2 to the other side. That essentially tells you that there is no difference between the population proportions. The second scenario that could occur is that both values for the interval could be positive. So that means that P1 minus P2, the difference has to be greater than 0. It has to be positive. And that indicates that P1 would have to be greater than P2. Same idea, just move the P2 to the other side of this little inequality. That tells you P1 has to be greater than P2 is what we're estimating. And then the third scenario is that both values for the confidence interval are negative. So that would be the opposite case. P1 minus P2 would be less than 0. And that indicates that P1 would have to be less than P2. Now, how you define P1 and P2 is up to you. Just be consistent throughout the problem when you're working out the example. But these are the three cases, and these are the things that you want to remember when you're making the interpretations. So let's talk about the general method. It's very similar and analogous to what we did when we just had one confidence interval. We are going to to build the confidence interval, we're going to take the test statistic plus minus Z star, remember, which was, we decided based on the confidence level, like if Z star, if the confidence level needed to be 95%, Z star was 2, for example. So that will be something you decide based on the level they ask for, times the estimated standard error. Now, the estimated standard error, I put where. The estimated standard error is sort of a lengthy formula. I am not going to ask you to calculate this by hand, but I'm going to write it so that you can have it and your notes will be complete in case you do need it down the road. But that would be P1 hat times 1 minus P1 hat divided by N1, where that's the sample size for the first sample, whatever goes with P1, plus P2 hat times 1 minus P2 hat, and this is all under the radical, divided by the second sample size. So if you put all of this together, this entire formula becomes P1 hat minus P2 hat plus minus Z star times that estimated standard error. Whew. It's an ugly formula. Do not bother to put this on your index card. You are not going to have to calculate these by hand. I promise we will either use StatCrunch to do the calculation, and then we will ask you to interpret it, or we'll give you the interval and ask you to interpret it. There are some conditions that have to be met. Remember, the central limit theorem still has to apply. I'm going to skip this for now because I don't want this video to get too lengthy, but essentially they're the same as what they were when we worked with one condition. Random and independent samples, large enough samples to expect at least 10 successes and 10 failures for each one. We just have to check both. Both populations have to be at least 10 times the sample size. And then the fourth condition is that the samples have to be independent of each other, which we will assume in our problems as long as they were taken randomly from the populations. So let's go back to this first example with our Democrats and Republicans. So I'm going to identify the two populations. And like I said, which one is P1, which one is P2? It does not make a difference. But I'm going to go ahead. I'm just going to call P1. I think that was listed first in the problem. So I'm going to call P1 the Democrats and P2 the Republicans. So let's write that down just to make sure we identify that. P1 is going to be the percentage of all Democrats who agreed with the survey question. P2 will be the percentage of all Republicans who agree with the survey question. If we let sample 1 represent the Democrats, what does 540 represent? 540, as you recall, was the number of Democrats that were surveyed, and then 537 were the number of Republicans that were surveyed. So N1 is the 540, and N2, while we're at it, would be 537. That's down here in part D. So N2 would be 537. 77% were the percentage of Democrats surveyed who agreed, so that would be P1 hat. And then 52% were the percentage of Republicans surveyed, so that would be P2 hat. I'm going to skip the necessary conditions. They are all met, so we aren't going to worry about that. Let's go ahead and fill out the rest of this, and then we're going to use StatCrunch to do our calculations. It says how many of those Democrats surveyed believed the bill will hurt middle income earners. Now, I'm bringing this up because how many of the Democrats surveyed? It would be 77% of the 540. The reason this is important is because when we put this into StatCrunch, StatCrunch requires us to put in the number who agreed with the statement, not the percentage. So basically, I'm doing 0.77 times 540 in my calculator. I'm getting a decimal 415.8. I'm just going to say 400 and we'll say 415. And then Republicans, how many? It's 52% of the 537. So that would be 0.52 times 537. Again, I have to put these numbers into StatCrunch. So that's why it's important for us to remember to do this calculation. That's giving me a decimal again. I'm going to round it to 279. All right, so then in StatCrunch, the process is the same as it was for a one proportion confidence interval. We're going to go stat, proportion statistics. We're going to select two samples this time with summary. So let me pause the video. Okay, so I've got my StatCrunch window open here. So I'm going to go stat, proportion stats, this time two sample with summary. And here is what I was referring to when you put this into StatCrunch. Just like with one population, you have to put in the number of successes. So for sample one, those were the Democrats. Remember, we had 415 out of 540 that we surveyed. And then for the Republicans, remember that we had 279 out of 537, and we want to do a confidence interval. I think they asked us to do a 95% interval, so I'm going to leave it as 95% default. And here is my data from StatCrunch. So this is the information, just like always, the lower limit and the upper limit that you want to pay attention to. So notice that both of these numbers are positive, 0.1937 to 0.3042. They're both positive. That is very important. Let's write this down. Let me go back to my Word document here. And we'll jot this down just so we have our notes complete from StatCrunch. It was, count one was 415 out of 537. No, I'm sorry, out of 540. That was the Democrats. So 540, I think, was the sample size. The other one was 279 out of 537. And by the way, I'm getting this directly from StatCrunch. Just make sure you see. I'm just copying it right from this table. The sample difference was 0.2489. I'm just going to round it to 0.249. So the difference in the sample proportions. Standard error, if we needed it, StatCrunch did that for us. It was 0.02818. So I'm just going to say 0.028. So then that lower limit was 0.1937. I'm just going to say 194. And then the upper limit was 0.304. So did the value contain, or did the confidence interval contain the value 0? No. Both limits are positive. Okay. So what does that tell us? Is there reason to believe then that the population proportion of Republicans and Democrats who believe that this bill will hurt middle income earners is significantly different? Yes, there is. And so because both limits were positive, that would be going back here to our second case. P1 is greater than P2. That's what we are saying. Okay. So, yes, this indicates that P1 is probably greater than P2. Let's go ahead and do a quick interpretation for the interval. So we know that the proportion of Democrats who believe that this bill would be harmful is going to be, the population proportion of Democrats is going to be higher. So let's write this down. So we could say something like we are 95% confident that the population proportion of Democrats, I'm just going to shorten this up and say who agree, is higher than Republicans by about, and you're going to use those percentages. So this suggests the difference between the two populations is somewhere between 19% and about 30%. So we'll say by about 19.4% to 30.4. Did I get those numbers right? 19.4 to 30.4%. So in other words, we think the difference between the populations is somewhere between 19% and 30%. higher for Democrats versus Republicans. And that's what this tells us. This gives us a way to compare those two population proportions. So bring your notes with you and we'll do some practice with this tomorrow in class.